Hi, everyone, and welcome to episode 683 of People Behind the Science. Today, we are excited to rebroadcast our interview with Dr. Melik Demirel, originally released on August 29th of 2016. Listeners, Malik is an expert in biosensors and nanomaterials. His lab works at the intersection of biology, materials science, and computational science to synthesize and fabricate new materials for a wide variety of applications, including energy, biomedicine, security, and defense. So listeners, get ready to hear more from another brilliant scientist in this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to People Behind the Science. Today, our guest is Dr. Melik Demirel. So, Malik, welcome to the show. How are you?
Good. How are you? Thank you.
I'm doing quite well, and we are excited to have you with us on our program today. So, listeners, Malik is a professor of engineering, science, and mechanics at the Pennsylvania State University. He received his bachelor's and master's in engineering from the Boğaziçi University in Turkey and was awarded his PhD in material science and engineering from Carnegie Mellon University. Afterwards, Malik conducted postdoctoral research at the Los Alamos National Laboratory, and he was awarded an Alexander von Humboldt Fellowship in molecular biology at the Max Planck Institute in Gottingen, Germany. He accepted his faculty position at Penn State in 2003. Now, Malik was also a recipient of the Young Investigator Award from the Office of Naval Research within the Department of Defense. He was selected as a Wyss Institute Visiting Scholar at Harvard University, and he was awarded the Outstanding Research Award from Penn State, among other honors during his career. And listeners, Malik is here with us today to talk a little bit about his research and also to tell us about his experiences in life and science. So, Malik, today we are excited to get to know you both as a scientist, but also as a person. So can you start by telling us how you spend your time when you're not doing science?
I like music. My brain works slowly. A neuron in your brain fires at the order of milliseconds, which is very, very slow compared to the other events in nature. Think about it. It takes tens of milliseconds to capture and process an image. So as scientists, we wanted to understand nature, but we are very slow to comprehend it. So this slowness, or I should say desperation, I believe pushed most of the creative minds to compose music or to create art to balance their happiness. I listen music for my happiness. It is selfish. But from classic music to romantic, Beethoven to Rachmaninov is my daily relaxation in the office. And at home, obviously, the family takes the lead. But overall, education, next generation of scientist people at home or at work is my daily focus.
I like it. And Rachmaninov, fantastic choice there. So do you perform music yourself or do you like to listen instead?
My kid does that. My older son plays both cello and piano, but I don't. My wife also plays piano.
Awesome. Well, very cool to hear a little bit about how you spend your time outside of science. I think you're absolutely right. Tapping into that creative side gives you a little bit of break from the scientific way of thinking. So now tell us a little bit about your science next and how you describe what you do to someone who's not familiar with your field or your research.
I'm interested in the question of complexity in both living and non-living systems. My research is at the interface of life, materials, and computational sciences. From gene regulation to biological circuits, biology offers us complex systems to study. So interaction in these biological systems are typically associated with energy, information flow, and so on. In the complex system community, so most of the scientists are interested in pattern formation. We see this kind of pattern formations in silk, for example, a natural protein. In bacteria, several things are happening in the order of seconds. Or on the cell walls, there are crystal-forming proteins, which are small enough, but all these systems form interesting patterns. So in general, we want to understand what are the physical basis of these patterns, and do they obey similar mathematical rules? Are the patterns have universal statistical patterns? Do these systems have some underlying mechanism? So these are the questions that we are very interested. The interesting part is, as a material scientist, we also see these things in non-living systems. examples, ferromagnets, superconductors, shape memory alloys, very, very similar phenomena. So independent of the origin, the underlying physical principles of the systems are very similar. So we wanted to understand or study the mathematical equations that are underlying this pattern-forming systems.
Well, I think this material science area is really cool because you're able to bring together, especially in your case, elements of biology, physics, chemistry, mathematics, all these different areas coming together. So I'm excited to chat more about the projects you have going on later in our interview, but I do want to talk a little bit for a moment about motivation. I think it can be hard to fit everything in a day. You mentioned that you have family at home, you have this interest in music. There's a lot of things going on in your life in addition to these big questions you're answering in the lab. So can you tell us, Malik, what motivates you? And do you have a favorite quote or saying that keeps you going during these very busy days?
I do have a very short inspirational motto. Do what you like what you do. I think this is a statement of freedom, and it's unconditional academic freedom, which goes back to von Humboldt. So it's the intellectual investigation of the world. I believe it's the key for academic success.
Certainly. Well, I think that is a great motto to keep in your mind. And I think it's particularly relevant for scientists because in many cases, we are so excited to go into work every day to get to work on the things we're studying. So like what you do, absolutely, and do what you like. So now tell us a little bit about some of these people who may have come across you in your career and may have served as inspirational figures or role models. You mentioned Alexander von Humboldt here. Is he one of them?
Absolutely. But I think the key question here, you can divide it into a realistic one and a more romantic or humanistic one. So obviously, my family had a big impact on my career. My father was a surgeon of ear, nose, and throat, and my mother was a biochemist, and my sister was specialized in family medicine. So I was the only PhD in the family of MDs. So most of the time, they made jokes about me because I have the PhD. But I should say I learned the first structure of a protein from my mother, which is a biochemist. So it goes deep into the family of these role models. But if you look at the realistic perspective of a career of a scientist, I'm much more interested to discuss ideas, being less interested in discussing people or events. As you know, there are many important scientists from Newton to Einstein, from Socrates to Nietzsche, who contributed to shape our current civilization. But beyond individual contribution, however, the future of the humanity depends on collective ideas, collective creative ideas. Therefore, I believe beyond one person. I believe in the plurality rather than singular role models. So it is a freedom. It is basically taking the direction of von Humboldt as well.
Certainly. Well, I love this idea of the real practical, the people who you're seeing face to face who are inspiring you along the way, but also this ideal of bringing together all these different ideas and thoughts and things of really the scientists that preceded you. So very cool. And now you mentioned that you are the only PhD in a family of MDs. And was there any pressure as you were growing up and as you started to go through your career to maybe pursue that MD path? Or did you face any expectations that you felt like you were disappointing anyone?
Actually, my father did not push me to get the MD because my sister is already becoming MD. So they achieved their goal. But beyond that, I think I find myself into the PhD program when I moved to the US. So it was a move that basically pushed me into looking into understanding of how nature works, how materials work, my interest. That pushed me to get a PhD.
Gotcha. So can you remember before you went off to get your PhD, was there a moment or a memory that really sticks in your mind as when you maybe first started getting interested in science?
My scientific life started when I was in college. I was lucky to work with one of the top polymer scientists. So he was one of the key person, I should say, pushing me to go into the PhD. I think that's a memorable event on my career.
So now can you tell us what attracted you to polymer science specifically? Did you have this interest going into college or was this something that happened more by chance?
I think it's definitely by chance. Even though, as I mentioned, my mother is a biochemist, I had a huge interest in biological molecules. I didn't know that proteins are polymers. So when I went to the college, I started learning about polymers and realized that proteins, biological molecules, are polymers as well. So that brings really the motivation in me, and I start focusing in that direction.
Interesting. And now moving to a completely different country, sort of across the world for your PhD is a big step. Were there things that you faced that were maybe challenges or surprises when you came here to do that?
Yes. So at the age of 24, approaching to half of my age right now, I moved to the United States. I first started at National Institute of Health. I was working there 6 months. And then I was also applying to the PhD programs. Luckily, I got into the Carnegie Mellon, and then I moved to Los Alamos and so forth. It was definitely a big step because not only the time frame is different, but it was moving from an Eastern culture to a Western culture. So it was a big move.
Certainly. Well, wonderful to hear a little bit about your career path and what has led you to where you are today. But can you tell us about one of these projects that you have going on at Penn State that you are so excited to be working on?
So we are working on protein assembly. Mm-hmm. Proteins are polymers, as I mentioned earlier. They provide a variety of building blocks for designing biological materials. And the last couple of years, we were interested in structural proteins, which have high strength properties. And we produce these things in the lab using industrial biotechnology. Think about a bacteria as a microscale factory. And this factory is creating these molecules. It's very similar to producing beer or wine. So we are working on creating these materials and making several different materials out of them. And one of the interests is how can we use these materials in the area of, say, orthopedic devices or textile or biodegradable gels for wound healing. Mm-hmm. These are areas that have so many impacts in daily life. So what we realize is the protein that we are working has an ability to self-heal. So you cut this material into two and you can put it back and it self-heals. And the magic is the hydrogen bonding inside the molecular architecture. So this is an exciting area right now that we are working on.
Very cool. So can you tell us a little bit more about this self-healing process? Do you have to add anything to make it heal, or is it something that happens just instantaneously without anyone intervening?
The protein material is by itself thermoplastic. It is very rigid. So it takes exactly the shape that you mold in or extruded any geometry that you want to. But then if you cut it into two pieces, so the magic is to soften the material. In order to soften this material, you need to add a small amount of water and bring the temperature, warm water, to bring the temperature above its softening temperature. And these are polymeric materials. So there are also on top of it hydrogen bonds, which takes the effect of healing. And therefore you gain back a reversible adhesion in this material. So it's reversible because it is governed by the hydrogen bonds.
Very interesting. Now, you touched a little bit on some of the applications of this technology, of this work that you're doing in the laboratory. And I think there are so many possibilities. And one of them I know that people are really excited about is this protective aspect. So people being able to wear these new materials in different environments to protect them, for example, from toxins. So can you speak a little bit more about that?
Absolutely. So imagine you have a tear in your jacket, right? An expensive one, right? So you want to fix it. You can fix it by taking a drop of water or a t-shirt that you can put it into the washing machine that will heal itself immediately. These are interesting applications in the area of textile, but there's also tremendous applications in the area of medicine where you can use these materials, for example, in hernia, surgical hernia. One of the key challenges currently is infection and the strength. So the meshes that are used in the human body has been invented in 1950s, but up to 1990s, there were absolutely no other solution but polypropylene, another polymer, but it was causing infections in patients. So the answer to that question come up from bioabsorbable meshes, but the problem turned out to be they bioabsorb fast. So a material that can have the ability to keep its strength, self-heal, at the same time minimize infection, had tremendous impact on patients who are waiting for surgery.
Certainly. So now talking about some of these applications, we've kind of mentioned that we potentially are interfacing with a lot of different types of scientists or clinicians. So we talked about these medical applications. I know there's potential applications in agriculture and manufacturing, textiles, things like that. So do you get to talk to these people and understand what you're developing your product for?
Yes, absolutely. On a daily basis. So basically, we are working with scientists from agricultural sciences. We are working with scientists from medicine, doctors, clinicians, and so on. We are also working scientists who are experts in other parts of materials. We want to make composite materials out of this on a daily basis.
Well, great to hear more about the work going on in your lab. But I think So far, we've talked about a lot of the high points of your career and the wonderful things you're doing in science, but we haven't chatted about a lot of the challenges, the struggles, the roadblocks. And I know every scientist has these, and you just have to face them in your career. And I think the young scientists out there need to be aware of what they're getting into. So we love talking about these challenges on our program. So Malik, can you tell us about a challenge or a failure that you had and how you worked your way through it to be successful?
Failure is daily part of scientist life.
Mm-hmm.
We fail 99 times out of 100.
Right.
We are not interested in the fame of success or seeking awards as trophies. We fail every day. But I think what pushes us moving forward is the opportunity of that 1% success. I think that's what's pushing us.
Absolutely. So can you tell us, you said we fail every day. What is a recent failure that you've had lately? It doesn't have to be a huge one.
Examples on a daily basis, I have multiple ideas to try. So we were trying to dissolve one of these protein structures. We have been using, for example, a solvent that we think that would help to stabilize a virus. And it turns out that it was destroying the virus capsid, which we never thought about.
Oh, no.
And we were planning to design the solvent for the protein. So it's not only experiments that you designed incorrectly, but it's also a learning curve for you to understand and evolve yourself to become a better scientist.
Certainly. So maybe if you've had a string of failures, if there are just a couple of days in a row where you are really banging your head against the wall, struggling to get experiments to work, what keeps you going, or what do you do to bring yourself back up?
As I said, 99 of 100, you fail. 1% possibility, I think, keeps us moving. So that 1% is good enough to see the light out of the tunnel.
I like it. Well, Malik, we don't just want to talk about the failures, the challenges, and the struggles. Let's focus now on that 1%, the successes, those happy moments in science. So can you tell us one of your own success stories, whether it's one of these huge successes or just a little win along the way that meant a lot?
Yeah, I think we had this 1% moment very recently. We discovered a new technique to screen protein sequences based on an ultra-fast laser spectroscopy technique. This is a very interesting technique. It simply looks at the refractive index of the material at the nanoscale, and you change the temperature because you are playing with a laser, so it will affect the temperature. But if you are heating a material, it will change the volume, it will expand.
Mm-hmm.
The key issue is how can you probe this material without expanding it, but changing its temperature? So two answers is you can cool it down, or you can probe this material very, very, very fast in the order of femtoseconds.
Wow.
Right? So it is basically a very fast technique that could help us to look at genes that are making these proteins. In simple terms, we are really squeezing the billion years of evolution of proteins into hours. So this is a development which has significant impacts on materials, agriculture, or medicine, such as neurological diseases, which are known to have aggregate proteins in the neurons, for example, for Alzheimer, Parkinson, and so on.
Right.
We can come up with a technique that can screen these genes in the order of hours with a very, very fast technique that is going to revolutionize the field. So that's a huge recent success.
So can you tell us how long was this project in the making before you realized success?
We have been working specifically on this part for the last 2 years.
Oh, wow.
And probably it will take another year to develop the high throughput technique. We already have shown it for small scale. We already have shown it for 4 or 5 different types of samples. But getting it to a large high throughput screening technique, it will take another year. So overall, 2-3 years is a good time frame to develop a successful project.
Certainly. So do you remember the first time you saw it working? Do you remember the circumstances around it?
Absolutely. It's quite interesting. You have an idea, and the first thing is there any physical or mathematical underlying theory or equation that can show that this is true? So as scientists, we are theory-driven people. We wanted to first see if there is an underlying principle that should say that this experiment will be successful.
Sure.
And that equation we have worked with through parallel while the students are collecting the data. And what we realized is we can correlate some of this femtosecond lasing technique with the crystallinity of these proteins with an equation, with a very simple equation. And later on, we start looking into the experimental results, and we realized that it perfectly fits. That moment was a big breakthrough in my life.
Well, that is amazing. I think just being able to overlay that and actually see that the theoretical, the equations match what you're seeing in the experiments in the lab, that is phenomenal. So how did you celebrate, Malik?
Well, go back to lab.
Yeah, I like it. Push on. There's more to do. Well, congratulations on developing this new technique that it sounds like has many potential applications in the future. And now we've talked a little bit about what you like to do with your time when you're not doing science. And I know I'm trying more and more to squeeze in more reading time in my day. So Malik, I'm hoping you can add a book to our reading list for my listeners and myself. So is there a book that you've read that you really enjoyed, whether it's a science book or a non-science book, that you can recommend for us?
Absolutely. But if you do the numbers, you can only read 2,000 to 3,000 books in your lifetime. So you have to be very picky. In any case, I like a book by Bernard Russell, The History of Western Philosophy. It's a classic. I enjoy reading it because as a native of Anatolia, the cradle of civilization, I should say, I can easily travel to the most of the ancient places that are within driving distance and visit the birthplace of most of these philosophers that are mentioned in the book that shaped our civilization through several millennia.
Interesting. So do you find yourself drawn towards these philosophy kinds of books or nonfiction kind of books in general?
I prefer reading more nonfiction, but from time to time, I made a list. It's also on my website. I recommend my own students to read, of course, classics as well.
Very good. Well, we will put this recommendation out on our website for our listeners to find. And we talked a little bit about travel throughout our description of your career path. And I think travel is a wonderful aspect of careers in science. You get to see so many places and talk to people from so many different places. So can you think back to all the places that science has taken you, Malik, and tell us about your favorite experience?
As I mentioned, we were working on structural proteins, and one of the structural protein comes from the tentacles of squid. I should mention that there are 350 different types of squid species around the world. And we were after 6 of them, and we had to travel several places in Mediterranean and east coast of US Atlantic, in Japan Sea and so on. So my biggest memorable experience was after spending 3 hours in the boat to catch the squid, I realized that I have motion sickness.
Oh, no.
That's a memorable trip. I learned that I have a motion sickness.
Yeah, now you can take preventative measures, the Dramamine. And so what was it like then being out there on the ship, going out and collecting these squid? Sounds like very different from your average day in the lab.
Yeah, I was basically hoping to reach the land as soon as possible.
Yeah.
I was almost vomiting.
Gotcha. So then can you tell us a little bit about other places that you've been for science or how much you're traveling in an average year?
I try to keep at home because of the family and so on, but definitely because of the workshops, summer schools and so on, I have to travel. But I should say less than 10%.
Gotcha. I think that's a good balance. I know some people I've talked to are traveling every couple of weeks. They're almost living out of a suitcase at that point, and I think that can be overwhelming. Thank you for sharing some of your travel experiences with us. So now, can you tell us about some of the people that you've worked with in science? I think some of these groups of people that we work with are phenomenal, and I know there are stereotypes out there about what scientists are like, and we try and break those on our show because I think there are so many different personalities in science, and sometimes these manifest through quirky traditions or just funny memories you share with your colleagues. So can you share one of your own stories, Malik, of the human side of science that showcases these personalities?
Yeah, absolutely. My students, they are the dangerous ones. They always want me to be out of the lab. Mm-hmm. And still, I want to resist and I don't want to listen to them. I want to go to the lab and do some experience. But most of the funny memories I had in the lab. So by definition, they are always young, right? So they are coming in their 20s and 25s and they graduate and the next generation comes in and so on. They are always young. And the only person that is aging is me in the lab. So you cannot catch their speed, their accuracy, or their precision. So obviously I pour the wrong solvent or make a small spill or mislabel something and cause major problem in the lab. So they try to kick me out of the lab.
So what did they do to distract you to get you out of the lab?
They find bureaucratic things that I should go and do, right? So
Gotcha. Well, Malik, wonderful to hear how your students are devising these elaborate schemes to keep you out of the lab so that they can maybe get in there, focus on their work. Well, wonderful to hear about your lab and some of the people that you're working with. And I think you brought up a really great point there that it's almost a revolving door. The students are always coming in, they work with you for a few years, and then they're moving on to different things. So can you tell us a little bit about what your experience has been like in mentoring these students and working with continuously new faces in the lab?
I typically have a small group, 10 to 15 people in the lab. So on average, it's always good. Sometimes you see personality issues and so on. But I think as scientists, we are learning how to deal with these situations in time. But overall, I enjoy it. I enjoy my students, research students, and I enjoy going to the lab. I enjoy discussing with them the research projects. Young minds, young ideas, new stuff. So it's really enjoyable.
Certainly. I think keeps you on your toes sometimes. So now we've talked about some of the awesome things that you're doing in the lab. And I think talking about some of these big questions you're trying to answer is a lot of fun for scientists. So Malik, I want to know about these big questions that remain in your mind, things that you have not been able to answer yet in your career. So is there one big question that if funding, staff, technology, feasibility, all these major constraints in science, if we took all of those away, what would you still want to answer?
I personally would like to work at the interface of psychology and life and material sciences. The reason is because I'm interested to learn more about our genes and their relation to our beliefs, such as sex, politics, religion. These have an interplay of both genetic and environmental factors in people's attitude, with mostly environmental factors playing a stronger role. But I want to ask the following question. For example, is there a God gene?
Interesting. Do you think there is?
I don't know.
Yeah.
If I have the funding, I would love to look into that.
Definitely. Well, I think this is a really unique spin on it. I've never had someone ask a question like this one, where you're kind of, like you said, playing at the interface of people's beliefs, the psychology of it, and the genetics, the biology of it. So very, very cool. Something for us to ponder, listeners. Well, now, Malik, we've talked about a lot of amazing topics related to your career, related to your life and your science. And I always like to give our listeners a little bit of advice that they can use in their own lives, in their own scientific careers. So is there one piece of advice that you can point to that someone gave you that was just the best piece of advice you've ever received?
My advisor, both PhD and postdoc, used to say, academia is a small world. Don't create waves, which I have not listened. So I've been creating small waves consciously or unconsciously, but they are small enough to perturb the system, not to destroy, but to perturb the system. I think my advisor's advice of not creating waves is a good one.
Certainly. I think you took at least part of it and you made small waves. Well, Malik, can you tell us, is there any last piece of advice or one last note of inspiration that you want to leave our listeners with today?
Yes, definitely. I was looking at the list of scientists who broadcast on this, and I really like different perspectives, different minds. And my suggestion is keep listening to this program.
I like it. Well, Malik, thank you. Listeners, I didn't even pay him to say that. So Malik, I really appreciate your support of our program, and it's been wonderful to hear your perspective on our program today. So can you tell our listeners, if they want to learn more about you and the work that you're doing in the lab, how should they get in touch?
Well, I check my emails very often, which is a completely bad habit. I want to get rid of it, but unfortunately I'm stuck to it. But Malik, MELIK @psu.edu is best way to reach me.
I like it. Well, I understand completely. I am addicted to email myself as well, so I can sympathize there. Listeners, definitely get in touch if you have any questions. And Malik, thank you so much for joining us today on the program and sharing your perspectives.
Thank you.
And listeners, thanks for joining us today. We appreciate your time, and we'll see you next time on another episode of People Behind the Science. Your voyage to explore the lives of today's exceptional scientists has just begun. You can find everything we talked about today, including our guests' favorite books, biographies, photos, and more, when you visit us at www.peoplebehindthescience.com. I look forward to chatting with you next time on People Behind the Science.